So yeah, I'm signal technologist at DirectOut. I also have my own independent consultant agency. I'm a tester for GATNM, AS67 evangelist, and a tool builder. My name is Nicolas Sturmel. And yeah, so 15 years of media over IP. 15 years of media over IP gives a quite wide heterogeneous ecosystem. You have Ravenna, Dante, SIMT, ST2110, SDVOE, Milan, NDI, AS67, IPMX, and other more. And the problem is that, of course, you cannot settle on one protocol. You will have one protocol for every use case, and on many installations, you will have to deal with multiple protocols. So, for instance, one of my clients has 60 different conference rooms on one campus, and is using Dante for audio. But for video, live feedback is using SDVOE because of the latency, and for streaming is using NDI for convenience. So this means that 3 different networks, 3 different protocols have to coexist on the same network. Another example is a live concert with a TV retransmission. So you would have Ravenna for part of the system, you would have ST2110 for the TV retransmission, but our good friends from live events, they chose Milan for their own network infrastructure. Milan is AVB, or also known as TSN for time-sensitive networking. And this is very interesting for us in the traffic shaping world because TSN it gives a lot of tools to do proper traffic shaping, but it's even another layer of complexity to deal with. So in theory, of course, in theory, you have the perfect interoperability protocol, and this is a slide that I steered from Andreas Hildebrand. This is a Ravenna slide that says, okay, with AS67, you can have any protocol you want, and they will all talk AS67 in audio, of course. But this is the theory, because in practical, you have a lot of incompatibilities, even within an interoperability standard. And this is because an interoperability standard needs to fit a specific use case. And the problem with AS67 is that we have a lot of different use cases, for instance. So this is just an example of 2 different devices that have a conflicting buffer size. So one device is allowed to send 0 packets for 10 milliseconds, so having a 10 millisecond gap in transmission, while the other one is allowed to have the minimum buffer size of 2 milliseconds. Oops, it doesn't work. And that's a real case event. I actually have customers complaining that they bought 2 different AS67 devices, but they cannot speak with one another. So reality check, well, we need gateways, and that was mentioned before. We need gateways in order to go from one network to the other and to have this this separation. And even then, even with the same network, we have different fields of working that do not trust each other. So again, I'm following the audio analogy because I'm an audio guy, but I'm sure you will be able to translate that in the video world. But you have the venue that wants its own network because they will not trust the guys from the front of house that will have their own network because they will not trust the guys from the OB-WAN to share the same network. So even though theoretically I'm allowed to transfer one Cat5 from one place to the other, in practical, there will be gateways because there will be isolation. There will be trust issues. There will be different requirements in terms of quality of service, in terms of addressing schemes, etc. There will be different technologies, including different switches, incompatible use of clocks, etc. And there will be different people because, well, interoperability amongst people is a whole lot different topic. Okay, so it's not, so the answer is not really interoperability. It first has to begin with coexistence. And I will not do a social parallel with that, but coexistence. So when you look at all those different services you find on the network, you find that for every protocol, they use the same types of services. They all use time. They all use transport. They all use control, and they all use quality of service. And yet they manage. So for the quality of service and the time, it is the most impressive. For the time, they all manage to use a different time protocol that are basically incompatible with one another. PTPv1 is not compatible with PTPv2. For the quality of service, some use no quality of service because they don't need it. Some use DSCP, some use TSN, which is a quality of service that is based on VLAN and traffic shaping again. By the way, very interesting for those ST2110 applications, and I'm sure the IEEE, the SMT will look into this in the future. But so the problem is the same as the rail problem. So if you're European, mostly you know about the rail shenanigans that we have in Europe. We are trying to have one single infrastructure, but we have one country in Europe, which is Spain, that uses a different gauge. A gauge, well, the spacing between the rails, and this leads to this kind of infrastructure in Spain. So the infrastructure where you have basically two different gauges in the same track. So when you are incompatible in terms of infrastructure, well, that's a no-go from the end, from the get-go. Then, of course, you need to collaborate on the infrastructure. And there is a very fun story that I like to say because, as you can notice from my accent, I'm French. And when Renfe tried to go into the French network, they needed a special signalization device to read the French signalization signal on the railway. And what did the SNCF, the French company? They bought every available devices of that just to prevent Renfe to go to the system for 2 or 3 hours, time from the manufacturer to build more. Fun? So yeah, once you collaborate, it begins to be interesting. It begins to be interesting because as a customer, you can choose what you need based on your requirements. And in train, yeah, there's the cost, but also there's the user experience, etc. And then it gets better. It gets better because at some point, you get services over your network that allow you to choose one train ticket with 2 different companies. So this, end of the metaphor here, but this is my utopia in terms of network convergence. I'm a tool builder, and I'm expecting every protocol to give me the most wide interoperability, or at least so service coexistence to be able to do that. And we do have a lot of problems. So let's put this slide in parentheses for a second, but in audio, we have a lot of problems with PTP because even if you use PTP version 2, you have different profiles. We have a lot of problems with the different IPs subsystems that are in use. So, okay, VLANs are easy. So the first solution is VLAN. Why VLAN? Because you get basically same infrastructure, but different method in the box. It's easier than air gapping because it's cheaper. You can use only one switch, less cables. But all switches do not manage IGMP, PTP, or multiple VLANs. So basically, you're screwed because you have to deal with limitations. And I invite you, for instance, to the Luminex booth in Hall 8. They have a lot of stories about that, for instance. Usually, those different VLANs are not routed because the technician doesn't know about routing. He's using audio over IP, video over IP, but routing? What's that? What? Oh, I can actually discuss between my subnets. And of course, so the problem is complicated. The addressing range can be messed up so that you have actually conflicting address range between those VLANs. and it's the Santipedic Ethernet PC. So I have seen on my customer the second slide with the 60 different conference rooms, some PCs with 5 different Ethernet adapters, just to be able to join one system. And this is an actual AV system. Okay, and then how do I transmit media from one domain to another? So back to the gateway. And okay, the gateway, it's cool. It allows to pass media from one to the other. It solves clocking issues, so that's fine when you don't want to mess with PTP. Basically, you keep your Dante its own clock, AES67 its own clock, ST2110 its own clock if you want to segregate AES67 and ST2110. It solves trust issue because I'm just passing audio between the tools, or for the video gateways, video. So I don't have to trust my colleague from the other room. And but it's not the most IT solution. And the IT guys, they have a lot of solutions when you do not trust someone, because basically we have a worldwide network right now that we call the internet, and it's working quite well at the moment. So while I do not trust my neighbor to, so okay. So conclusion yet, how many times do we have still, Tina?
You are fine. You've got it's 1:37.
Okay.
You've got about 10 minutes.
10 minutes, cool. So lots of time for questions. Because it's Andy's pace of speaking. I took the same, but I was not prepared. No, that's cool. So yeah, so the approach needs to be holistic. We need to, so again, I understand that from the video perspective, it's a bit different, but yet Andy gave me plenty of reasons to think that it applies to video too. The holistic approach, we need to see the system as a globality and not just interconnections of different competing systems or different production systems. We need to see beyond the workflow and within the whole architecture of what do I do in my broadcast, and how do I merge my different workflows. We also need to see the media network as a collection of services. And for instance, not specify ST2110 as I use PTP version 2 profile X, but first I use a clock. And if PTP v2 clock is available, then I use that. And in this way, NDI is really interesting because NDI has a lot of different ways of synchronizing two different clocks. So it leads to a complication layer, an added complication layer to the manufacturers. But in terms of interoperability, you can choose the right products that gives you the interoperability you want. Okay, yeah, and of course, you have other IT-specific protocols like spanning tree bandwidth, and let's talk about TSN, for instance. So 3 months ago, I joined the company that just entered the Avenue Alliance that is pushing TSN, and I learned a lot about TSN. And it's really interesting how 2110 specifies traffic shaping, but do not really give tools to do so, while TSN has a lot of tools for traffic shaping. And basically, you can. What is fun with TSN is you can have a TDM network. With TSN, you can have your Ethernet network that just translate to TDM. Okay, so this is done, and yeah, no, I went on the other side. Okay, so yeah, open to questions now.